4 years now, Ukraine has had to deal with constant Russian bombardment as enemy drones and missiles rain down on its towns, cities, and infrastructure. Some of those missiles have the power to level entire buildings in an instant, killing dozens and wounding many more. So, it's vital that Ukraine intercepts and eliminates as many as it possibly can. But there's one big problem. Even with aid from its Western allies, Ukraine only has a certain number of interceptor missiles. Fortunately, Kiev's forces have yet again proven their remarkable resourcefulness and ability to adapt and innovate under pressure, coming up with a truly genius way to bring down Russian missiles without having to fire a single shot of their own. Introducing the Lima, a domestically developed electronic warfare (EW) system capable of disrupting even Russia's most powerful drones and missiles, sending them spiraling hopelessly off course, so instead of striking their intended targets, they often end up landing in empty fields. It does this primarily by generating powerful jamming fields that essentially disrupt the missile's satellite navigation systems. If the missiles have no navigation, they're far less likely to reach their destinations and hit their targets with their usual high levels of precision. They can still continue to fly, relying on the inertial navigation systems to assist them, but their accuracy takes a big hit. To be more precise, they can veer around 2 kilometers, 1.2 miles, off target for every 100 kilometers, 62 miles, traveled. But that's not all this system is capable of. In fact, there's much more to the Lima than meets the eye, with some military experts classifying it among the most technically impressive EW systems ever invented. It was created by a company called Cascade Systems, which started off as just another Ukrainian defense sector startup, but has gone on to become one of the major players in this war, providing the country with an invaluable and irreplaceable piece of its increasingly complex air defense network. A representative from Cascade Systems, who also serves as a commander in the Night Watch, one of Ukraine's leading electronic warfare units, and goes by the nickname Alchemist, recently sat down with Politico to share fresh details about how the system works and why it has proven to be so effective. When Lima is on, it makes missile deviation even greater. In addition to simply suppressing navigation, we use spoofing and the substitution of coordinates by several kilometers. We can make their missiles fall in fields instead of hitting their targets. Here's a deeper explanation of how that actually works. Lima doesn't just block satellite signals so missiles and drones don't know where they're going. It can actually emit spoofed or fake signals, effectively feeding false information directly into the enemy weapons. According to Lima's developers, they've successfully managed to divert Russian attacks by making the enemy's missiles think that they are in Peru. With completely confusing coordinates embedded in their guidance systems, the missiles veer wildly off track and have almost zero chance of hitting the target. It's important to remember, too, that these are expensive assets. Even though Russia has a reasonable amount of missiles to maintain the pressure of its attacks, it doesn't like seeing these kinds of munitions go to waste. A Kinzhal Hypersonic Missile, for example, costs around $10 million per unit. That's a huge amount of money to simply throw into an empty field. Every time Lima helps to bring down one of these costly munitions, it represents a serious financial loss for the enemy. And the system's extraordinary abilities don't end there. During the Politico interview, Alchemist also revealed that Lima has the power to create invisible but incredibly effective dead zones around key areas, like towns and cities. If any enemy drones or missiles enter those zones, they immediately lose their guidance signals and have no way of knowing where they're going or how to reach their intended targets. This obviously requires the use of multiple Lima systems, since each one has a limited range. But by combining systems' powers and placing them in the right areas, Ukraine's forces can easily protect the places that matter the most. As Alchemist explains, when we create a wide enough zone, protected by Lima stations, a missile won't even hit the city. We will send it into an open field. The beneficial implications of this technology are extraordinary. Let's say, for example, that Ukraine wants to protect a particular town, a piece of infrastructure, like a substation or water treatment facility, or some other site of strategic importance from Russian drones and missile attacks. In the past, the only option it would have had would be to set up expensive air defense batteries around that area and hope that there were enough of them to deal with any incoming threats. Even then, there would always be concerns about the batteries running out of interceptors or huge swarms and salvos saturating the systems, allowing some to pass through and deal vast amounts of damage. Plus, there would have to be entire teams of operators in place at all times, scanning radar screens and helping to repel enemy attacks. With Lima dead zones, however, all Ukraine's military has to do is place these systems in the correct locations, Sit back and watch as the EW technology nullifies any aerial threats that get too close. It's easy, autonomous, and extraordinarily efficient. And it's getting better all the time. In the past, for example, the Lima was highly effective against most Russian drones and some missiles, but struggled against some of the more heavy-duty munitions in the enemy's arsenal, like glide bombs. These bombs, which are little more than standard bombs fitted with special winglets to help them travel further distances after launch, were always harder to counter, since Russia almost exclusively uses them in front-line locations. The front lines are fluid and territorial control is often shifting back and forth, so it was almost impossible for Ukraine to install its Lima systems in the correct areas to create glide bomb dead zones. There was always a risk that Russian forces would move in, spot the systems, and take them out. To make matters worse, Russia also developed anti-jamming antennas that had attached to its glide bombs, allowing them to bypass most EW systems without being disrupted or missing their targets. Fortunately, Lima's developers didn't let up. They worked tirelessly, day in and day out, to improve their technology and find ways to make it more powerful, effective, and impactful. It took time, but eventually, they found out how to overcome the Russians' anti-jammers. Soon after that, Lima began diverting glide bombs, massively reducing their accuracy and the consistency with which they were able to strike their intended targets. As Maxim Skoretsky, head of the EW Department of the Land Forces of Ukraine, explains, it doesn't take much to nullify these weapons' capabilities, even if the glide bomb deviates from its target for about 20 meters. It already means the target will continue to exist, said Skoretsky. Again, this is so vital. While Russia largely relies on drones and missiles to strike places in Ukraine that are dozens of miles behind the front lines, it has carried out countless bombing runs along front-line locations, like fortified settlements, contested villages, and supply routes that help to feed Kiev's brigades. These bombs are relatively cheap, precise, and easy to use. Russia can launch them from relatively far inside its own regions or occupied territories, typically using high-speed fighter jets, which are very difficult for Ukraine to intercept or disrupt in any way, as they can quickly release their bombs and retreat to safer locations. From there, the bombs glide towards their targets, using antennas to evade conventional EW technologies and remain on course for their targets, and many of them carry quite weighty warheads, often tipping the scales at 500 kilograms, 100 pounds, or even significantly more. This allows them to deal massive damage on impact, obliterating bunkers, fortifications, trenches, and troop concentrations. Even if they're slightly off target, the impact of the shockwave can still be enough to deal serious damage and injuries to anyone in the area. However, thanks to the Lima, Ukraine can't completely counter the glide bomb threat, but it can significantly reduce it. That, in turn, should result in fewer frontline losses, while also making it much harder for Russia to penetrate the Ukrainian defensive lines and push on to make the territorial gains it needs to succeed. The Lima isn't perfect, however. Before we dig into some of its downsides and how Ukraine is addressing them, you're watching the military show, and if you haven't subscribed yet, now's the time. While the Lima's technical capacities are impressive, it's not a panacea for Ukraine's air defense problems. There are issues with relying too much on a system like this. The biggest of those issues is the fact that even if they've had their signals and guidance systems disrupted, jammed Russian drones, missiles, and bombs still need to fall somewhere and can still deal damage as a result. Missiles might miss their original targets by a few miles but still end up spiraling into another building, for example. Drones can fall out of the air but land on houses and vehicles. And even bombs that land in farmers' fields can still generate enough force to damage local power lines. This is where conventional air defenses have the advantage. When you fire an interceptor missile at an incoming drone or missile, it usually blows up in the air. Some debris may still rain down onto buildings below, but it's usually in such small pieces that it doesn't deal anywhere near as